Alright, this experiment is chemical reactions with copper. Now, some places call this the copper cycle. Because what we're doing today, you're starting the experiment with some copper. It'll actually be a small ball like this. Copper metal, that's where you're going to start. You're going to take this copper metal through a series of 5 reactions. You're going to take your copper metal, react it with nitric acid. That's your first reaction. That gives you copper 2 nitrate. You'll then react the copper 2 nitrate with sodium hydroxide. That's your second reaction. And you end up with copper 2 hydroxide. You then take that copper 2 hydroxide, you heat it up, and it turns into copper oxide. So that's your third reaction. You then take the copper oxide, you dissolve it in sulfuric acid. That's your fourth reaction. Gives you copper sulfate. You then add zinc metal, and guess what you end up with? You end up with copper metal, right back where you started. So you're going to start this experiment with a little ball of copper, and when you're all done in your evaporating dish, you should have another piece of copper. But if it looks like a penny, we figured you probably cheated. Okay, here's our copper metal, all wrapped up as a little ball, and here's the concentrated nitric acid. Copper doesn't react with most acids, but boy does it react with nitric acid, as you can see. So we just add the nitric acid drop by drop until that copper metal is gone. The red gas you're seeing is nitrogen oxide being given off by the reaction. You see that blue-green liquid, that is the copper 2 nitrate. It's absorbed a little bit of water, so it's kind of aqueous, and it's giving you that blue color. So again, copper metal and nitric acid give a fairly vigorous reaction. Okay, there's our copper metal after it's been dissolved in the nitric acid. It now is copper 2 nitrate. We're going to add a little bit of water to that, and there's a nice blue solution of copper 2 nitrate. Okay, this is our copper 2 nitrate. We used an excess of the nitric acid, so this solution is quite acidic. We're going to add some sodium hydroxide, 6 molar sodium hydroxide to it. And initially, the acid and the hydroxide should destroy each other, and then we start to get a nice blue precipitate of the copper 2 hydroxide. Now, we got to make sure the solution's basic, so we occasionally check it with some litmus, and you see how it's not, well, that is basic. Yeah, we've added enough hydroxide to make the solution basic, and what you have there, that kind of blue sludge, that blue sludge is your copper hydroxide. You see that kind of sludge? That's our copper hydroxide. Okay, here's our blue sludge of copper hydroxide. We're going to add a little bit more water to it, and we're going to boil it. And so we're applying heat, and we're going to get that copper hydroxide to decompose into copper oxide. That's a general property of metal hydroxides. If you heat them up, they turn into the corresponding oxide by eliminating water. So to heat this, we should have some boiling chips in there. We'll stir it continually until it boils, and at that point we should have our copper oxide. You can see how as we're heating this, it's getting darker and darker. That's the blue copper hydroxide beginning to decompose and form the black copper oxide. Okay, and you can see it's been heating up a little bit longer. It's turning into a black precipitate as opposed to a blue precipitate. Okay, that's our solution of copper oxide. I'm going to turn it off, and what you'll see is the copper oxide is a much more dense precipitate. So within a few minutes we should have a nice layer of black on the bottom and nice clear water on the top. Okay, that copper oxide, we want to isolate it. We're going to isolate it by gravity filtration. Got a big sheet of filter paper. And the way this works, you fold it twice. Give yourself a little cone. Get the little edge there. Pop it in. Get it wet so it stays put. And there's our filter cone ready to roll. Help if I put a beaker under it. Okay, clearly you can see the top layer is pretty clear, and the bottom layer is that black muck. That's the copper oxide, the black mud that you're seeing there. And you can see that the copper oxide is a much more dense precipitate, so it sinks to the bottom. Okay, now I'm going to isolate that copper oxide by filtering it here. Okay, so here's our black muck of copper oxide. Now I want to rinse that off with some nice hot water. The reason we do this is it's not pure copper oxide. It's got some nitrate ions from the earlier steps. If I don't get rid of those nitrate ions, I'll have some problems in step 5. So we'll take some hot water here and use that to rinse the copper oxide. And that should get rid of all those excess nitrate ions. Okay, so here's our copper oxide, which we've just washed with hot water. We want to get rid of that wastewater. That's got those nitrate ions we're trying to get rid of. Now we're going to take our copper oxide and we're going to dissolve it in sulfuric acid here. Okay, so we're going to dissolve our copper oxide in sulfuric acid. I have 20 mils of sulfuric acid. We'll pour that in. And it will take a minute or two, but you'll start to see a blue solution of copper sulfate come out the bottom. Now, the 20 milliliters of sulfuric acid is not really enough to dissolve all that copper oxide. So what we're going to do, as it comes through, we'll take some of it and put it back in the top. If I keep doing this, in a few minutes, all that black muck of the copper oxide will be dissolved, and we should have a nice blue solution of copper sulfate in our beaker. You just keep reusing the same sulfuric acid over and over, and I think you should start to see how the solution's getting more and more blue as that copper oxide dissolves. Okay, we'll put a piece of tissue paper there so you can, against the white background, it's just a little bit more obvious that the solution's turning blue from that sulfuric acid dissolving the copper oxide, and it produces the nice blue copper sulfate. You see how it comes out with a little bit of the oxide, but eventually that oxide dissolves. So, and there's our solution of copper 2 sulfate right there. There's our nice blue copper 2 sulfate. Okay, here is our solution of copper 2 sulfate, and to get our copper metal back, this is the last of the 5 reactions. This is reaction number 5 in your book. We're going to add some pieces of zinc metal, nice big chunks of zinc. So we'll add a couple of those. You'll notice that they're bubbling and fizzing. That's because it's giving off some hydrogen gas. But over time here, you should start to see some little chunks of brown powder forming, and that brown powder would be our copper metal coming back out of solution. So we'll let that sit for a few minutes and then take a look at it. Okay, you see the bubbles coming off, that's the hydrogen gas. Hopefully you're seeing some little flecks of brown powder. The brown powder is, of course, the copper metal coming back out of solution. And you see some of that brown powder forming there in the middle. And I'll stir it up more and more, and that helps the copper ions to find the zinc metal. And we're slowly but surely getting our copper metal back. You see that brown powder there. That's our copper metal. Okay, so the reaction's been going a while. You're seeing that some of the blue color is fading. How do we know when we've gotten all of the copper back? That brown in the middle, is that reddish brown stuff, is our copper metal. Well, when all of the blue color is gone, that means we've recovered all of our copper metal. So we'll just keep stirring and stirring, and after a few minutes it should be colorless, and that would indicate that we've recovered all of our copper metal. Okay, and I've been stirring this mixture, waiting for that blue color to fade, and at this point I'm not seeing any more of the blue color, so I think we've recovered all of our copper. You can see that our copper metal is this brown red powder, and the zinc that we added, that'd be our 2 big chunks of zinc metal. So there's our copper metal. It comes out as a reddish brown powder. Okay, to figure out how much copper we've recovered, we're going to start with an empty evaporating dish and weigh it. So we'll know the mass of the empty evaporating dish. Then we will transfer our copper powder into the dish. I'll transfer it by simply washing it in there. Here's our copper powder. We'll decant off the water. Oops, lost a little copper there. We'll dry it by putting it on a hot plate over here. We'll let that sit on the hot plate until it's nice and dry. Some mild heating for a little bit, and we have a nice dry copper powder that we can then weigh. So I weighed the evaporating dish when it was empty. Now I simply weigh it with the copper inside of it. By subtracting, I'll be able to figure out the mass of the copper.